Hello. More examples of the physics EMPA, things that you can be asked to do. Let's show you this one. This was one of our favourites. There's a large setup of equipment here. Obviously, you may see some things. This was set up on the desk already when people arrived. In the booklet, it showed a picture, slightly neater than my one here, but it showed a picture to get the idea of what we were going to do here. You may just want to zoom back so you can see this. This is essentially the idea. A ball let go from just below that fixed mark there will run down the ramp and land on that yellow piece of paper. Can you see everything from where you are? Okay, here we go. 5, 4, 3, 2, 1. Okay, if I just show you that on the board, the ball is designed to roll and arrive horizontally coming off there. It will then follow a parabolic path down to ground, which we know already from our looking at free fall last term. How could we measure something in here? Well, again, you'd be very precisely told what to measure here. In this example, this is what we had to do. Using a set square and a ruler, we can start by getting a measurement from where the bottom of the track is down to the ground. So, set square on the floor, ruler next to it, make sure that is vertical, and marking then where that is, our start point. That's where the ball left the track. Where did it land? Well, in this situation, an unusual technique, using a bit of carbon paper placed on the track, this would happen. If you just want to pan back from there, I'll show you the whole thing. 5, 4, 3, 2, 1. Nothing different. And yet, when it hit this, it leaves a trace on the track that we can see. So we could actually highlight where it hit. And using a ruler, could measure that distance sideways. Okay. Now the fun starts. This was also given to each person. You had to do this in this experiment. Put that at the right place so that when the ball comes off the track, it hits that nail on its way down. Obviously, it may take a few goes to get it right. Let's try one. 5, 4, 3, 2, 1. Didn't work. Try another one. Didn't work. Close. Yay! Oh, sorry. It worked. Now at this stage, we could again use a ruler and a set square to get a measurement directly underneath where that hit. So, set square on the floor, ruler against it, check it's vertical to there. Okay. That then is what we had. If I show you on the board, what that meant was we put the extra stand and target in there so that it hit that one. And we measured that point there. This experiment then had a mark here, a mark there. That's one distance. Call that x1 in this experiment. It also had a mark here, so we could measure that distance, x2. When you'd done that, you were then instructed to move this downwards, also backwards to keep the track running, and do the whole thing again. And do that 6 times. So, as you can imagine, a lot of moving about required in this one, a lot of adjustment to get 6 different values for x1 and x2. But once you'd written those down, then, as you might already have suspected, we plot a graph. Not the best graph I've ever drawn in my life. We plot a graph. And in this case, a graph of x1 there, x2 there, turned out to be a straight line graph. And again, plotting the graph wasn't too bad. Once we got the measurements, wasn't too bad. But using the equipment in this case was quite challenging. Being able to follow the written instructions detailing this was quite challenging. It was also quite challenging for us, this one. We had to set 15 of these up in a room. And of course the ball didn't stop, rolled away, got away, people walking all over the place. It was quite fun, we really enjoyed it. 2 hours of listening to teenagers' balls drop, as we like to call it. Okay, what a great experiment. More next time. Bye.